Bismillahirrahmanirrahim. Start with the name of Allah Almighty. Assalamu alaikum students. Welcome to the virtual study phase 3, lecture 1, mathematics of class 5. Let me introduce my team. Remember, Ma'am Nasra and me Sir Ishan. We have already covered one chapter in previous phase. Now we are starting with chapter number 2, HCF and LCM. First of all, we have to know that what is HCF. HCF, also known as highest common factor, which is the greatest number in a group of common factors of two or more numbers. And LCM is a least common multiple, which is the smallest number in the group of common multiples of two or more numbers. We will discuss these two definitions in detail in the upcoming lecture. In this lecture, we are focused on factors and multiples, and also a divisibility test. Now, what is a factor? A number that divides another number dividend completely without leaving a remainder is a factor of that number. For example, the factor of 10 are 1, 2, 5 and 10. On the right hand side, there is some terminology of division, like the number at this place I am indicating is dividend. The number at this place I am indicating with the red dot is quotient. The number at this place is a divisor, and the number at this place is remainder. In this case, the remainder is 0, which I am indicated as a cross sign. Now, we are seeing that when 10 is divided by 1, leave 0 remainder. When 10 is divided by 2, also leave 0 remainder. When 10 is divided by 5 and 10 is divided by 10, leave 0 remainder. So we can say that 1, 2, 5 and 10 are the factors of 10. In other words, 10 is divisible by 1, 2, 5 and 10. So recall the definition: a number that divides another number dividend completely without leaving a remainder is a factor of that number. I hope you clear with this concept that what is a factor. These are the factors: 1, 2, 5, 10 are the factors of 10. Similarly, factors of 3 is 1 and 3. Factors of 8 are 1, 2, 4 and 8. Now, what is a multiple? The definition of multiple is: a multiple of a number is a number obtained by multiplying that number by any natural number. For example, the natural numbers are the counting numbers starting from 1, like 1, 2, 3, 4, 5, 6, 7 and so on. Natural numbers are also called counting numbers, which we use in daily life. For example, the multiples of 9 are 9, 18, 27, 36, 45, 54 and so on. The numbers which I am indicating as red color are natural numbers, and these numbers are multiples of 9. When 9 is multiplied by 1, which is equal to 9, 9 is multiplied by 2 is equal to 18, 9 is multiplied by 3 is equal to 27. These are the natural numbers. These are the multiples of 9. When 9 is multiplied repeatedly by a natural number, it gives us multiples of that number. Let's recall the definition. A multiple of a number, which is 9, is a number obtained by multiplying that number by any natural numbers. So the multiples of 9 are 9, 18, 27, 36 and so on. What is mean by divisible? Sorry, this is chapter number 2, not 5. 5 is your class. Chapter number 2, HCF and LCM. What is mean by divisible? I will explain this definition by below example. In this division, 50, let's say 50 is the first number and 2 is the second number. So 50 is completely divided by 2. So we can say that 50 is divisible by 2. Divisible means if the first number divided by a second number leaves no remainder, then we say first number is divisible by second number. First number is 50 and second number is 2. If first number divided by second number, 50 is divided by 2 leaves, if 50 divided by 2 leaves no remainder or zero remainder, then we can say first number means 50 is divisible by second number. Divisible is very relative to factor. We can say that 2 is a factor of 50 or 50 is divisible by 2. Next subtopic is test of divisibility. Now what is divisibility rule? A divisibility rule is a short way to tell about factors of a required number without doing lengthy calculations. Without doing lengthy calculations, we directly tell that the required number is a factor of another number or not. For example, divisibility of test of 2 says that if the number at its unit place is 0, 2, 4, 6, 8, then the original number is divisible by 2. Look at this first column from the right. This is a unit column. This is a place value chart. Which you know in the previous classes you are working with place value chart. This is a place value chart. The right from right side, the first column is a unit place value. If the unit place of any number is 0, 2, 4, 6 and 8, then we can say that the whole original number 2730 is divisible by 2. Similarly, 8532, 834, 676 and 2448 is also divisible by 2. Next divisibility test is 3. Divisibility test of 3 says that if the sum of the digits of a number leads to the multiple of a number, or we can say that if the sum of digits of a number is divisible by 3, then the original number is also divisible by 3. For example, 105. 105 original number is 105 and the digits of that number is 105. If we sum of its digits 1 plus 0 plus 5 is equal to 6. Now we know that 6 is divisible by 3. If we divide 6 by 3 the quotient is 2 and the remainder is 0. So the original number 105 is also divisible by 3. Next example. Original number is 2091. Sum of the digits are 2, 0, 9 and 1, which is equal to 12. Now we know that 12 is divisible by 3. So original number is also divisible by 3. Divisibility test is a shortcut to determine that number is divisible by some other number or not, which is mainly 2, 3, 5, 6, 8, 10, 11, etc. 25 also, etc. Now, another example. Now the original number is 2730. Sum of the digits are 2 plus 7 plus 3 plus 0, which is equal to 12. Now we know that 12 is divisible by 3. So the original number is also divisible by 3. Next is divisibility rule of 4. Divisibility rule of 4 says that the number formed by the last two digits of a number is a multiple of 4 or 0. If we want to check that the required number is divisible by 4 or not, we have to focus on last two digit of that number. If the last two digit of that number is a multiple of 4 or 0, then we can say that original number is divisible by 4. In this example, 96 is a multiple of 4. If we multiply 4 with 24, we get 96. So 96 is a multiple of 4. So we can say that 1996 is divisible by 4. Similarly, 2000 is also divisible by 4 because the last two digits of 2000 is 0 or 0. Divisibility test of 5. It is very easy divisibility test. This test say that the number ends with either 0 or 5. If the number ends with 0 or 5, or we can say that the unit place of that number is 0 or 5, then we can say that number is divisible by 5. Divisibility rule of 6. The divisibility rule of 6 say that the number should be divisible by 2 and 3. First of all, for the divisibility test of 6, we have to confirm that number is even or that number is divisible by 2. For the divisibility of 2, we check the unit place. If the unit place is 0, 2, 4, 6, 8, then we can say that number is divisible by 2. In these two examples, the unit place is even or 2. So these two numbers are divisible by 2. Now we have to check whether these numbers are divisible by 3. So we sum up its digits. 8 plus 6 plus 2 plus 2, which is equal to 18. 18 is divisible by 3. So we can say that these original number 8622 is also divisible by 6 because this number is divisible by 2 and also divisible by 3. So the condition fulfills. So this number is divisible by 6. The below example is 39,582, which is a very large number as compared to previous one. If we simply uh, check by doing lengthy calculation, we consume a lot of time. So divisibility rule help us to save much more time in easy way to tell whether it is divisible by some number or not. In this example, we have to check that it is divisible by 2 or not. It is divisible by 2 because in its unit place it has even number or 2, so it is divisible by 2. And we have to check also that it is divisible by 3 or not. Sum of the digits are 3 plus 9 plus 5 plus 8 plus 2, 10, 19, 24, 27, which is equal to 27. Now we know that 27 is divisible by 3. So we can say that these original number 39,582 is also divisible by 6. Divisibility rule of 8 is also similar to divisibility rule of 4. In divisibility rule of 4, there we check the last two digits. In divisibility rule of 8, we check the last three digits. The number formed by last three digits is a multiple of 8 or 0. For example, this number is divisible by 8 because the last three digits are 0. This number is divisible by 8 because last three digit is a multiple of 8. If we multiply 8 with 51, we get 408. This whole number is divisible by 8 because last three digit is 600, which is a multiple of 8. So these three digits, so these three numbers are divisible by 8. Divisibility rule of 9. The sum of the digits the sum of the digits of the number is a multiple of 9. Same as divisibility test of 3. We sum of the digits of these original number 2 plus 5, 4 plus 5 plus 7 is equal to 18, which is a multiple of 9. This in the below last example of this rule, if we add up the digits of the original number, we get 27, which is also multiple of 9. So we can say that these original number is divisible by 9. Divisibility rule of 11, which is in your mind bender, I think so, in your book. These test this test is not included in your exercise. I see that this test and test of 25 divisibility test for 25 is your math slash or mind benders game. So I'm explaining a little bit. In these two examples, you almost clear your concept because these are 6-digit number. Divisibility test of 11 says that the difference between the sum of alternate digits of a number is 0 or a multiple of 11. First of all, we broke this definition into two different parts, two or three. It's alternate digits. Alternate digits mean alternate positions. If you start from the first position, the next alternate position is 3, and the other alternate position is 5. If we start from the second position, the alternate position is 4, and then alternate position is 6. So in this definition, it says the sum of alternate digits of a number, not the position. So we have to sum the alternate digits like 1 plus 3 plus 8. We say this is an odd place for your easiness. We say these places are odd places. Sum of the digits in the odd places is equal to 1 plus 3 plus 8, which is equal to 12. And the sum of digits in the even places means alternate positions is 0 plus 0 plus 1, which is equal to 1. So we now covered these one and two points. Now we come to the third point, which is the difference between the sum. These are the sum if we find the difference between these two sum, which is equal to 12 minus 1 is equal to 11. As the definition says, the difference between the sum of the alternate digits of a number is 0 or a multiple of 11, then the whole original number is divisible by 11. As we can see that the difference between the sum is 11 alternate digits, sum of alternate digits is 11, so the original number this is divisible by 11, also divisible by 11. The last example of this lecture, these are the alternate positions from above and from below. I say these are odd digits, odd place digits, and these are even place digits. Some of the digits in the odd place is equal to 7 plus 9 which is equal to 25. Some of digits in even places is equal to 14. Difference between the sum is equal to 11. As the difference between the sum of alternate digits is 11, so the original number is divisible by 11. These divisibility rules are very handy when we want to find that the required number is divisible by some other number like 2, 3, 5, 2, 3, 4, 5, 8, 9, 6, 11, etc. And now slightly look at these previous examples. These are the alternate position, and these are alternate position from below. Some of these positions are 1 plus 3, which is equal to 4. Sum of digits in even places is equal to 4. Difference between them is 0. So original number is divisible by 11. Like this, 1 plus 6 is equal to 7 and 6 plus 1 is equal to 7. The difference between these two sum is equal to 0. So the original number is divisible by 11. Now today we learned what is a factor and what is a multiple and divisibility rules of 2, 3, 4, 5, 6, 8, 9 and 11. So today's diary students the diary today is page number 29, question number 4 to 8 for practice. I have when you practice your diary, you notice that I put these that exercises question as my example. So these your practice will be more easier. Thanks for watching. If you have any query or any question, feel free to ask in the required time. If you did not understand any point, kindly again see this video, or if you do not understand after seeing again this video, you can ask from me in the required time. Thank you so much. Thanks for watching. Allah Hafiz.